All right, so let's talk about all the different key features I want to ask for if I give you a graph of a polynomial. Here I have a graph of a polynomial. Let's just call this f, make our life easy. And everything I want to ask you about this graph is domain, range, x-intercept, y-intercept, relative max, relative min, increasing, decreasing, and then behaviors. Now I'm going to have short videos on most of these. Domain and range we've already been talking about, but the other ones I'm going to have short videos explaining a little bit more in detail. So this is going to be a typical type of problem if I give you a graph. I'm going to ask you for all of these key features. So right off the bat, let's just start. My domain of any polynomial is from negative infinity to infinity. My range is going to go from my lowest y or my highest y, just depends. So I'm going to look at my y here. My lowest y is going to be at 0, and then my highest y is going to infinity. So it's from 0 to infinity. My x-intercept, there are three different things I could call it. I could call it an x-intercept, a root, an x-intercept, a root, oh, I'm drawing a blank, or a 0. So all three of those mean the same thing. X-intercept, root, or 0, it basically just means where is it touching the x-axis. You just use it those different words in context of the sentence. Like if I'm asking you to find the zeros of a polynomial, that's where it's crossing the x-axis, but I'm asking you from an equation. All right, in this case, my x-intercepts. Now, because these are points, I want an x and a y value. Well, I have a point at -3, 0, and I have another x-intercept at 3, 0. My y-intercept, well, conveniently, there will only be one of these because it's a function, so it'll only ever have one y-intercept, and that's a point as well, so I'm going to want it as a point. And that's right here, which is going to be 0, 1. Now, my relative max, or my relative min, well, let's talk relative max. That's basically a maximum that's not the end behaviors. It's these little curves in the middle. So if I look here, this part is a low point, so this is a relative minimum, and I'll go more in detail on how to figure this out in a different video. This one here is a relative maximum because it's kind of curving here, and then this one's a relative maximum. Now these are also points, so my relative max occurs at 0, 1. My relative minimum, well, they occur at -3, 0, and at 3, 0. So those are my relative max and relative mins. Well, like I said, I'll go more in detail in a different video. All right, so increasing and decreasing is really, you're going to look at individual air regions, and if I had to say, if I was drawing a line in just that part, is the slope positive or negative? If the slope would be positive, that's going to be increasing. If the slope is going to be negative, that'll be decreasing. I'll go way more in detail. There's an easy way to think about this. So on this graph, when I'm going to look for increase, I'm going to look for things that are rising from left to right. Now, right here at these turning points, there's no slope. It's not increasing or decreasing, so we're never going to use a square bracket. So it's increasing at -3, and it's going to go up to 1. And then we're going to skip past this because this part's going down. We're going to the next part where it's going up. So here's my union. And I'm going to go to 3, and then it's increasing to infinity because it's always going up. Hold on, there's the bell. Okay, so now let's talk about decreasing. Decreasing is where the graph is falling when you're going left to right. So I'm going to start at the leftmost. So here it's decreasing from -infinity all the way to -3. And then I'm going to skip because this part was increasing. But now if you look, this part's decreasing. So I'm going to skip over to 1, and it's decreasing all the way up to 3. So it's increasing in these parts because it's increasing, it's rising left to right. And it's decreasing here because it's falling. When I do the video of it, I have a funny little way to think about it. It's actually really easy. And now my end behavior, well, we're just going to look. And now we're going to write this in limit notation, and we're going to say the limit as x approaches -infinity. So as my x is going this way, my graph is always going up. And this is of f of x. Well, this is going to be, well, it's going up to infinity. All right, so now we're going to do the other one. The limit as x approaches infinity. So as x is going this direction, it's also going up. So here's f of x, because this is a graph of f, and that's also going to infinity. So this is if I give you a graph, I'm going to ask you for all of this, and you're going to have to be able to give me all of these. Now I'm going to make some individual videos on, I'm pretty sure you can figure out the X-intercepts, that's where they touch. But we'll do a video or Y-intercept for the graph, but I'll show you algebraically how to find the Y-intercept. We're going to build you up to the X-intercept. That's going to be a whole different section. These relative maxes and relative mins, I'll do a video on those graphically, and then increasing and decreasing, I will do a video on them graphically. And then the end behavior, there's a video of explaining the connection between Algebra 2 and pre-calculus, the way we're going to write it. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.